The Arctic, 14.5 million square kilometers of ocean, ice, and permafrost, 1/5 of the Earth's water supply, an estimated 22% of the world's natural gas and oil, and where 6,000 species of animals and 5,900 species of flora have made their home. For an environment whose temperatures easily dip into the extremes, it is both vast in its biodiversity and rich with natural resources. This makes it a valuable asset for exploration and development, both to preserve and to utilize. However, the average winter temperature of the region is minus 34 degrees Celsius, while the summer temperature is only a moderate 3 to 12. This, coupled with the fact that it is sometimes difficult to navigate the Arctic terrain, makes it problematic to carry out any kind of activity. Fortunately, people have found solutions to deal with the Arctic climate, and mechanical engineers certainly play a big part in these solutions, particularly in the aspects of travel and material. One of the main issues associated with Arctic exploration is travel. There is a wide range of environmental conditions in the region. There are layers of permafrost, rocky terrain, and of course, ice and snow. One solution was to get a truck. A really, really big truck. The company known as Arctic Trucks has been taking Toyota vehicles with four-wheel drive capabilities and modifying them for use in rough environments for over 20 years. And these vehicles have been field tested in both expeditions to the North Pole and glaciers in Greenland. The modifications to these trucks are extensive, particularly on the tires. The tires have large footprints, which aim to decrease the pressure on the ground, and the tire itself is larger, in order to provide more clearance from the ground and reduce the load on the suspension, making it ideal for traveling over rough terrain. Additionally, modifications to the gearbox of the truck can be made to lower its gear ratio. The gearbox of a vehicle converts the movement of the pistons in the cylinders of the engine into movement of the wheels. A lower gear ratio results in more cycles of the pistons per revolution of the wheels. This is ideal for climbing a hill. When scaling a hill, the vehicle has to counteract the effect of gravity, in addition to friction and drag from the air. Therefore, the lower gear ratio is helpful for the engine in this regard. Of course, designing a vehicle for off-road expedition won't be any good if the material of the vehicle happens to shatter upon impact. So, another aspect of Arctic exploration that must be tackled is material strength. The term tensile toughness refers to the measure of a material's ductility. It is often calculated by taking the area underneath a stress versus strain curve. A material with high ductility tends to deform before fracturing, which means it has high tensile toughness. On the other hand, a material that shatters instead of deforming has low tensile toughness. So how does this relate to our topic? It turns out that things aren't as easy as finding a material with high tensile toughness, as a lot of materials experience a shift from ductile behavior to brittle behavior once the temperature drops to a certain point, known as the ductile to brittle transition temperature, or DBTT. The lower the DBTT, the more a material can withstand cold temperatures. Therefore, it is desirable to find a material with a low DBTT. Research shows that materials with a body-centered cubic lattice arrangement has a sharper shift between ductile and brittle compared to materials with a face-centered cubic lattice. Face-centered cubic materials, such as aluminum, copper, and gold, are candidates for low DBTT. It is important that we find ways to improve upon aspects of exploration. From what we've talked about, it is clear that mechanical engineering plays a major role in this process. Thanks for watching.